Hi, I am Ching Jiang from the Australian National University. This work is about a simple question. What is affordance for a visual system? Affordance is often evaluated as a mask prediction task. Given an image and an action phrase, for example, where should I hold, a model predicts a region. But this formulation hides a deeper question. What makes that predicted region actionable? Why is it an affordance, rather than just a verb condition segmentation mask? Our view is that affordance connects visual understanding to embodied action. To localize an affordance, a model needs at least two complementary cues. The first is geometry. What object structures exist, such as handles, rims, blades, or grips? The second is interaction. How an action engages with the object, or where the action is likely to contact the object. In this paper, we ask whether these two cues already exist inside pre-trained vision foundation models, and whether composing them can explain affordance localization. In the second section, we first probe geometry. If affordance depends on object structure, then models with stronger geometric awareness should better support affordance localization. We test this using frozen visual foundation models and a lightweight probing setup. Across models, we find that depth and normal estimation errors correlate negatively with affordance MIOU. In other words, better three-dimensional geometric awareness tends to predict better affordance segmentation. We also visualize dino-style features and observe that they naturally expose part-level structures in cluttered scenes. This suggests that these representations contain useful geometric primitives for affordance reasoning. Next, we probe interaction. Our hypothesis is that generative models, especially image editing or image generation models, learn action-object interaction priors because they need to synthesize plausible interactions. We analyze verb-conditioned attention in flux context. The qualitative examples show that verb attention highlights plausible contact regions for actions such as holding or typing. We also compare this signal with grounding dyno, mask clip, and EVF SAM on AGD20K. Flux context achieves the strongest NSS score among these alternatives, suggesting that generative attention contains a useful interaction prior, not merely object semantics or generic segmentation. The final section asks whether these two primitives can be composed. This is the key test of our argument. We use Dyno v3 features to obtain part-level geometry cues and flux context verb attention as the interaction cue. We then select geometry components that best align with the interaction prior and fuse them into an affordance map. This pipeline is training-free. It does not use affordance labels, task fine-tuning, or test time adaptation. The qualitative results show that the fused prediction can localize action-relevant regions for different actions, such as holding and cutting. Quantitatively on AGD20K, adding geometry to the interaction-only prediction improves the result, especially reducing KLD and improving SIM, while remaining competitive with supervised or weakly supervised baselines. This supports the idea that geometry and interaction are not just descriptive concepts, they are operational signals that can be probed and composed. The takeaway is that pre-trained vision foundation models expose two imperfect but composable affordance primitives, geometric structure and interaction prior. Our goal is not to claim that these models have embodied understanding in a human sense. Rather, we show that affordance reasoning can be studied mechanistically by asking what internal visual capacities make an action-relevant region possible.